This video looks at some MATLAB files which focus very specifically on the analysis and design of feedback loops for first-order systems. We've agreed that feedback is important and an obvious endpoint to a first course in control. And feedback changes behaviour, and we want to understand those behaviour changes and whether there are patterns. It so happens that there are clear patterns with first-order systems, so here we're going to look at MATLAB files which explore those. Reminder then of common feedback loop expressions, and here if we focus on a first-order model, there's a first-order model, you can see there are clear dependence in the closed-loop transfer function on the parameters a, t and k. So we wish to create and analyse this feedback expression and exploit this in design. The MATLAB files then we've got to support the analysis of first-order systems. The main two we're going to look at now are these two live script files on first-order models. There are also some apps which we'll talk about in a minute. A reminder that you should make sure you've gone through the earlier files on first-order behaviours, video 6, because they're a useful foundation. And there are many apps and GUIs which focus on this sort of area, and we'll look at those in a separate video for brevity. And a final reminder, the purpose here is not to teach you MATLAB, but to expose you to some of the MATLAB files that you can use to basically reinforce your understanding of control and also your understanding of MATLAB as required. So let's go to the live script files then. So the first one, first order models and feedback. So I can just run this file, make sure it's fresh, and you'll see the first thing that you can do here is it's got two sliders that you can use to change your choice of first order system. Section 1 then compares open loop and closed loop with a compensated gain of 1. So you can see there's some core commands here and some basic figures. So you can enter your system up here and then look at what happens if you have unity negative feedback. Section 2 then allows you to explore a bigger variety of compensator values. So you'll see this slider here currently at 1.7. I can change that, and you'll notice the figures here basically overlay the plots for a number of different compensators. So each time you change the slider, you'll get the plot added to the figure. Now, it so happens for this system the choice of timescale is probably not particularly good, but you can change the code and modify the timescale if that works for you. Okay, now the next file is a start to finish modelling and design file. It's to encourage you to think about how would you go about it from the very outset. The first section just reminds you what you did a few weeks ago on first order behaviours. So you can vary the different parameters and get first order responses and understand time constant and gain. What's more important is we want to do some modelling. So how would you go about modelling? So it's a reminder that from a step response you can estimate the time constant and the gain. So these parameters t and c. So where do we do that in anger? We do that in anger here in section 3. So you'll notice the original data is given in blue and your current estimate for the model is in blue. Now if you is in red, sorry. Now if you look, I can see that the steady state gain is going to be about 19. So I'm going to put 19 down there. The time constant I reckon it's going to be around 10. I'm not going to be over precise because I don't want to waste time here. And then if I run section, it will update my plot. And you can see the steady state gain's about right, but maybe I've got the time constant a little too fast. So you can work on that. And so the first step, get your time constant and gain correct. Once you've done that, we come down to doing proportional control. So this first section looks at what happens if you have a proportional control of 1, and you can decide whether that's any good or not. It's for you to play with. Section 5 then allows you to explore more widely a whole variety of different compensator gains. So here you can see I've got 5 values of k, and you'll see the plots are overlaid there, so you can have a look and say, what do I think? What happens as these compensators change? What value would I like? And obviously you can change these sliders as it suits, okay, to have the values that you want in that figure. Section 6 introduces PI. So now the idea is you can start exploring PI design, and again you'll see PI compensation given down here with some default values, and you can use the slider to change those values. And you can see here are the plots down here. Here's the legend with your KPKI values. So if I change KI, then your plot should update accordingly. And if we go down to section 7, see section 7 includes what's called a heuristic design. Some conclusions then. We've demonstrated MATLAB files which allow students to develop an understanding of how to analyze, design and quantify system closed-loop responses and behaviors, but with a focus on first-order systems because they're a special case, but a very common special case.